Department of Mathematics, SNS College of Technology. So today we are going to see the topic properties of eigenvalue. As you all always know that the mathematics plays a very important role in every field. The properties of eigenvalue also plays a vital role in many fields like computer science, mathematics, then engineering. In every field the properties of eigenvalue is used. So in depth if we calculate the properties of eigenvalue for a covariance matrix, it helps us to find the directions of the matrix. So let us briefly see the problems based on the properties of eigenvalue. So we have the two major properties. The number one, sum of the eigenvalue. So for a 3 cross 3 matrix, we know that we have 3 eigenvalues. So the sum of all the eigenvalue of a matrix is equal to sum of the main diagonal. So instead of finding all the eigenvalue and adding, so we will get the sum. Instead of finding all these, we can just add the sum of the main diagonal, that will be equal to the sum of the eigenvalues of that matrix. So this is the property 1. The property 1 is sum of the eigenvalues of a matrix is equal to the sum of the main diagonal elements. So the next property is product. Product of the eigenvalue is equal to the determinant of the eigenvalue. As we all familiar with finding the determinant of a matrix, so finding the product. So it's a very big process. That is, first we have to find all the eigenvalue, then multiply it. Instead of doing this long process, we can just find the determinant of the matrix. It will be equal to the product of the eigenvalue. So we have the two major properties of eigenvalue, that is sum of the eigenvalue is equal to the sum of the main diagonal element, and product of the eigenvalue is equal to the determinant of the matrix. So let us use these properties to do the problem. So first problem, find the sum and product of the eigenvalue of the matrix. The given matrix is named as A, minus 1, 1, 1, 1, minus 1, 1, 1, 1, minus 1. So what is the order for this matrix? It has 3 rows and 3 columns. So order of this matrix is 3 cross 3. When matrix is of order 3, we have 3 eigenvalues and correspondingly we can get 3 eigenvector. So the problem is not finding the eigenvalues, we have to just find the sum and product of the eigenvalue. Sum of the eigenvalue. Sum of the eigenvalue. So the property states that the sum of the eigenvalue is the sum of the main diagonal element. So this is your main diagonal element. So 3 main diagonal elements. If we add this main diagonal element, we will get the sum of the eigenvalue. That is minus 1 plus minus 1 plus the diagonal number is minus 1. So the sum of the eigenvalue is equal to minus 3. So next we have to find the product. Product of the eigenvalue. Product of the eigenvalue, as we stated that it is equal to the determinant. So we will calculate the determinant of this matrix. Minus 1, 1, 1, 1 minus 1, 1, 1, 1 minus 1. So if you find the determinant of this matrix, it will be the product of the eigenvalue. So let me expand by the first row. So minus 1. If you consider this element, you have to delete that corresponding row and corresponding column. So deleting the rows and column, we will get minus 1, 1, 1, minus 1. The next element is 1. So minus that, deleting the corresponding row and column, I will get 1, 1, 1, minus 1. The last element is 1 plus 1. Corresponding to the rows and column deleting, we will get 1 minus 1, 1, 1. So expand this, minus 1, cross multiplying, minus 1 into minus 1 is 1, negative minus of 1 into 1 is 1. minus 1 multiplying 1 into minus 1 is minus 1, minus of 1 into 1 is 1, plus 1, cross multiplying 1, minus into minus 1 is plus 1. So finally we get 1 minus 1 is 0, minus 1, minus 1 minus 1 is minus 2, plus 1 into 1 plus 1 is 2. So finally we get 0 and minus is plus 2 and this is plus 2. So 2 plus 2, 2 plus 2 equal to 4. Hence we get the product of the eigenvalue is equal to 4. So for this problem we get the sum of the eigenvalue is minus 3 and product of the eigenvalue is 4.